Welcome everyone. This is part 2 of the introductory video on the SCION secure internet architecture. In this video, we continue to discuss the reasons why we need a new internet. In particular, we will look in more detail at motivations for change. What are the worst security problems that we're faced in today's internet? You may think of many different issues. You may think of malware, including worms, viruses, etc., spyware, ransomware, advanced persistent threats, HTTP-based attacks, spam email or phishing email, compromised IoT devices, and so on and so forth. However, these are not really internet security problems. These are really all end-host security problems. Instead, I'd like to offer an alternative viewpoint of what the worst internet security problem is. And you can see this based on the observation that the most basic purpose of the internet is to deliver data from point A to point B. And so the most fundamental security issue is thus network availability. And so an attacker will attempt to prevent communication, attempt to prevent availability. For instance, by disrupting the routing system, by performing address hijacking attacks, or DDoS attacks, which stands for Distributed Denial of Service attacks. In the following videos, we're going to explore how we can achieve this most fundamental network property, which is high availability. How we can achieve this high availability despite an active attacker that attempts to prevent us from communication. But first, let's take a look at the most fundamental networking protocol to find paths in today's internet. The BGP protocol was designed in 1989 by Lougheed and Rector, and it's specified in the document called RFC 1105. The initial design fit on 3 napkins, so it's sometimes referred to as the 3-napkin protocol, as you can see the 3 napkins at the bottom of this slide. Since its inception, BGP has become one of the most important internet protocols as it determines the networking paths from a source towards the destination. And it's perhaps the most important network protocol that many people don't know about. While the BGP protocol has served us relatively well so far, it unfortunately has several shortcomings from a security and reliability perspective. In fact, in terms of availability, BGP has frequent periods of unavailability when path change. So even if there's no network failure, simply if one of the systems in the network decides to change a path, it often occurs that there's a brief routing loop which can last for a few seconds, and during which packets cannot be delivered that are unlucky enough to travel on that specific path. BGP also suffers from slow convergence, and it has an iterative route computation that can sometimes takes a long time to converge. In the worst cases, we've seen convergence times that have been in the tens of minutes until the network found stable paths. BGP is also susceptible to attacks and misconfigurations, sometimes resulting in global outages. BGP also has poor transparency. It has poor path predictability as well as reproducibility, as we've seen in the previous video. BGP also offers almost no path choice by endpoints, and thus has very limited control that it offers to senders and receivers. Also, there's a trust problem in that the secure version of BGP, called BGPsec, uses very few trust routes. And this can lead to single points of failure that can be attacked by an adversary. On the next 3 slides, I'm listing problems of today's internet. And I'm not going to go through all of these because it would take too much time, and it would fill several videos to go through all these points. But I just want to highlight the magnitude of all the different issues that are plaguing BGP as well as the internet control plane. We see that the BGPsec protocol, which is the secure version of BGP, also again introduces new issues that the original BGP protocol did not have. As well as for the internet protocol itself and the data plane, there are also several issues and also several miscellaneous issues that are plaguing today's internet. You can look at these in detail based on the slides, which you can download from our webpage. So the question is, if there are all these different problems in today's internet, what solutions are ready? So People may think of the following solutions. There have been the solutions of SDN, or blockchain, or cloud computing, and some people actually argue that these are the solutions to all the problems we have in today's internet. So let me briefly discuss about each one of these in turn. SDN stands for software-defined networking, and it's a new routing protocol that one can use inside a domain for data delivery. However, SDN is really an intra-domain protocol working inside one domain and not across all domains as large as the internet. In fact, the internet requires an inter-domain routing protocol, which SDN cannot be because it would not scale to the size of today's internet. Also, blockchain technologies used in Bitcoin are currently very popular, and some people think that one can solve all the problems with these new technologies. However, blockchain also requires communication, and so it itself also relies on an operational internet, and therefore you cannot build an internet based on a blockchain, as this would be a circular argument. Cloud computing itself also is a new powerful mechanism, but cloud computing also relies on inter-domain networks such that the different clouds can communicate as well as hosts can communicate with the cloud. There have been several proposed future internet architectures that researchers have worked on over the past 2 decades. While security was considered in many of these future internet architectures, it was in most cases much more of a secondary design goal. So none of these architectures really have security as a central or core design goal, nor propose a comprehensive security architecture. What's actually also surprising is the absence of interdomain routing innovation. And so as Ken Calvert noted in his keynote at ICMP 2016, very little has changed in interdomain routing over the past 15 years. And in fact, most of the innovation happened at the lower and upper layers of today's internet, but not really in interdomain routing. The figure at the bottom represents a 7-layer OSI model. The width of this figure represents the different types of protocols that are used at each layer. We can see that IP, the Internet Protocol, and the Border Gateway Protocol, BGP, represent the narrow waist of this hourglass figure. And this means that there are very few protocols that are operational at this part of the networking layer. So most of the innovation that happened really happened at the bottom, at the link layer, but the vast majority of updates have happened at the application layer. So one may wonder, why are actually the problems that the internet is faced with not being addressed? So the question is, if the internet is so important and has so many problems, how come they have not been addressed yet? And on this slide, I offer 2 possible explanations. The first explanation is represented by this Titanic scenario. We're overly confident that everything is just fine. The second scenario is called the boiling frog scenario. We don't realize the severity of escalating threats, and as the water is getting hotter and hotter, the frogs do not jump out of the pot and eventually get cooked. And possibly, the actual reason may be somewhere in between these 2 scenarios, but they're interesting to think about. Perhaps an alternative explanation also is sweat and human ingenuity. In today's internet, we have thousands of clever system network administrators who are working very hard to keep the internet up and running. And thanks to the sweat and ingenuity of these individuals, despite all the issues of today's internet, it's actually working relatively well. There's also a belief that the internet is immutable. People oftentimes mention evidence that seems overwhelming that the internet cannot be changed. In particular, they mention IPv6 or BGP-SEC or DNS-SEC, which took a very long time to introduce, and also even today, in some cases, are still not available. However, if one really considers these aspects, the benefits that have been provided by IPv6 or BGP-SEC or DNS-SEC were actually quite limited, especially for early deployers and early adopters. And so instead, our goal is to provide a lot of benefits, especially for early adopters, such that one finds itself in such a good environment that they cannot go back to the current internet. We compare this to business class air travel. If you've once flown business class, it's very difficult to go back to economy. Another example is the iPhone or an Android smartphone. Once you use one of these devices, it's very hard to turn back to a feature phone and use that phone as you've used to. So the question should not be, why switch to a new architecture? But once you use the new architecture, I hope the question will be, why did we put up so long with the current architecture? On this slide, let's discuss evolutionary versus revolutionary change. If you study today's problems of the internet in more detail, you find that a lot of problems are truly fundamental. They're not simply fixable through a simple evolutionary change. So the more you study this problem, you realize that a revolution is really necessary. It's not an option in order to really fundamentally improve today's internet. A revolutionary approach is also desirable. So with a fresh redesign, you can clearly incorporate new mechanisms and achieve with a very nice, clean network architecture. One part we've been surprised by is that a revolutionary technology change is actually quite easy through an evolutionary deployment. And in fact, we're going to make use of the Internet Protocol IP and relegate it to provide simply local intra-domain communication. And so only a very small fraction of routers actually need to change. We can also operate simultaneously with current Internet protocols, and so still achieve very strong properties that provide a motivation for deployment. I hope you are now convinced that we need a new internet. In the next video, we will look at an overview of the SCION secure internet architecture to get an intuition of how we can solve all the problems we have discussed so far. For more information, please visit our website. Chapter 1 of our book discusses the material we've seen in this video in more detail. You can purchase the book from Springer Verlag, or you can download the PDF from our website. Thank you for watching.